In this video, we discussed about the instruction set of 8085 microprocessor. An instruction is a binary pattern designed inside a microprocessor to perform a specific function. The entire group of instruction that a microprocessor support is called instruction set. As we know, 8085 is a 8-bit microprocessor, then it has 256 instructions. Each instruction is represented by 8-bit binary values, and these 8-bit binary values is called opcode or instruction byte. The instruction set are divided into following sections: data transfer instruction, arithmetic instruction, logical instruction, branch instruction, control instructions. In this video, we discussed about data transfer instruction. These instructions are used to move data between two registers or between memory and registers. These instructions copy data from source to destination without changing the original data. Let's see. Move. This instruction is used to copy the data from source register to destination register. Move source register to destination register. Source register to memory register. Move memory to destination register. These instructions copy the content of source register into the destination register using instruction move source register to destination. And for memory, we use HL pair to specify the memory location. For example, move A to B. Before execution of this instruction, the data is stored in accumulator. After execution, the data is present in both the accumulator and register B. For move B to M, here the memory location is specified by the HL pair register. Then before execution of this instruction, the data is present in B register, and after execution the data is copied to the memory location which is specified by the HL pair. Similarly, for move M to C, the data is copied from a memory location which is specified by the HL pair to the register C. Move immediate 8-bit data. In this, the operand is a 8-bit data with a register. The 8-bit data is stored in a destination register or memory. For memory, again the memory location is specified by the HL pair register. For example, MVI B60H. Before execution, the B register is empty, and after execution of this instruction, the data is copied to the register B. So, register B has 60 hexadecimal data. For MBI M40H, the data is moved to the memory location which is specified by the HL pair. So, after execution of this instruction, the data is stored to the memory location 2050. Load directly accumulator. Here, Operand is a 16-bit address. The content of memory location specified by 16-bit address in the operand are copied to the accumulator. After the execution of this instruction, the data of source are not altered. For example, LDA 2000H. Before execution, the data is present at the memory location, and after execution of this instruction, the data is present the memory location as well as the accumulator. LDAX, load accumulator indirect. It is 1 byte instruction and the operand is a register pair, either BC pair or D pair. The content of designated register pair point to a memory location. This instruction copy the content of the memory location into the accumulator. The content of either the register pair or the memory location are not changed. For example, LDAXD. Here, the memory location is specified by the D register pair. Before execution, the data is present in the memory location, and after the execution of this instruction, the data is present at the accumulator as well as memory location. LXI, load register pair immediate. Here again the operand is a 16-bit data with register pair. For this instruction, generally we use HL pair. Before the execution of this instruction, the 16-bit data is present in the HL pair. After the execution of instruction, the data is stored in the HL pair register. The content of address 2030 is copied into lower order L and 20 is copied in H register. HLD, load HL register direct. This instruction copy the content of memory location pointed out by the 16-bit address to the register L. Then it is copy the content of next memory location into the H register. For example, LHLD 2030. Before the execution, the data is present in 2030 memory location and 2031. After execution of this instruction, the data of 2030 is copied to the L register and 2031 is copied to the H register. STA. Here we store the data of accumulator to the memory location, which is specified by the operand. So, the content of accumulator are copied into the memory location specified by the operand STA 2000H. After the execution of this instruction, the 8-bit data present in the accumulator copied to the memory location 200H as shown in this example, after execution of this instruction, the data of accumulator is copied to the memory location. STAX, again it is a 1 byte instruction and store the accumulator indirect. Here, the content of accumulator are copied into the memory location is specified by a register pair, generally BC pair or DE pair. For example, STAX B, the data of accumulator is stored to the memory location which is specified by the BC register pair. SHLD, store HL register direct. This instruction contains 16-bit address. The content of register L are stored to the memory location specified by the 16-bit address, and the content of H is stored to the next memory location of the address. For example, SHLD 8500. After execution of this instruction, the content of L register is stored to the memory location 8500, and the content of H register is stored to next memory location 8501. XCHG, exchange HL register with D register. The content of register H are exchanged with the content of register D, and the content of register L is exchanged with the content of register E. After the execution of this instruction, the data is exchanged with the HL pair register with the D pair register. PCHL. This instruction is used to copy the data to the program counter. Here, after execution of this instruction, the content of HL pair are copied to the program counter. The content of H are placed as the higher order byte and the content of L as placed at the lower order byte. Push register pair into stack. After execution of this instruction, the content of register pair are copied onto the stack. For this instruction, the stack pointer is decremented and the content of higher order register like B register are copied to the stack, and again the stack pointer is decremented and the content of lower order register is copied to the C register. Similarly for D and E and H and L. For example, push H. After the execution of push H, the content of data is copied to the content of H register is copied to the memory location 2098, and after the decremented of stack pointer, the content of L register is copied to the 2097. Pop. Pop is stacked to register pair. After the execution of this instruction, the content of top of the stack are copied into a register pair. The content of location pointed out by stack pointer are copied to the lower order register, and after this stack pointer incremented and the content of location are copied to the higher order register. Like this, pop h here the content of data is copied to both the memory location. In copy data to the accumulator from a port with 8-bit data. Here, after the execution of this instruction, the data of output or input port are copied into the accumulator. The port address is given by the operand. This is the example. In 80, before instruction, the data is present at port 80 and accumulator is empty, and after the execution of this instruction, the data is copied to the accumulator. Out, copy data from accumulator to port with 8-bit address. Here, the content of accumulator is copied to the input-output port, which is specified by the 8-bit port address. Thank you. This is all about the data transfer type instruction.